What's up guys, today I'm very excited to bring a video on custom object detection with YOLO version 12, a revolutionary update from Ultralytics. YOLO version 12 boosts higher mean average precision than YOLO version 11, although it trades a bit of speed for accuracy. In this video, I will walk you through collecting custom object images for free and using a free annotation tool called Labelme to label them, and performing all the essential steps to train YOLO version 12. So stick around to see the magic in action. These are the prediction results, and these are the test data set. On the test data set, it correctly identified 6 objects, 6 yarn corn objects with high confidence and high probability. And the other one is this one. It also correctly identified 5 objects which are yarn corn and with their corresponding probability, confidence probability, and they are all high. So let's go and see the code in action. We want to do custom object detection, and since we don't have the dataset, we need to prepare the dataset. We need to first find the images of the custom object and then annotate them. So in order to find the images, we go on the Google to install a new extension called ImageEye. As you can see, I search ImageEye extension on Google Chrome. It appears here, and I installed it before, so it is installed and it is here. I have it, and then I go for the custom object, yarn corn object, and these are the images of the yarn corn. And then I go here, and I wait to find all the images of yarn corn, and it's finding 266 images. Now it counts. So I chose the ones which are at least 70 to 70, 17 width and 17 height. So as you can see, there are 142 images, and after that I want to download it. I select all and I download all of them. So I wait to download all of the images. Okay. Meanwhile, I go to PyCharm to start labeling and annotating the objects, custom objects that are being downloaded. So here in this folder I am doing object detection, and first I run the command Labelme. It's the free annotation tool for Python to annotate the images. And then you go here, open dir, Google search. These are the I go to the download part, Google search, and selecting this folder. As you can see, the images come, and then you go and create edit, create a rectangle, and then you specify the objects, and then you call this yarn cone. This is the first one. By clicking, it's very easy to use. The next one also yarn cone, and the next one, as well, yarn cone as well. So, and then you saved it, save to a new folder, called annotations, and here I save it as 1, and I go to next image. So you annotate all the objects, all the yarn corn in this way, and then it will produce the JSON files in that specific folder that you chose. You annotations, this is the first one that I annotated. It has this form, and as you can see, they are the label, yarn corn, the object, and the heights and widths of the objects, and the center of that. As you can see, some of them have the names, and these are the names of the data type. And then after you annotate all the images of the custom object, for example, it depends on the object. If it is very hard to recognize or detect, you need to annotate up to 200 or 300 images. For now, I just downloaded 70 images, and I annotated all of them, the 70 images of them. And then I show you for the first one that we annotate with each other. It is in annotation file, and I cut it from here to put it in my directory that I have the codes for the object detection, and this is the name of the folder. So here I want to specify a trick. First, the annotations are in JSON format of the Labelme. Labelme has a specific format for annotation of the images. We need to convert it to the YOLO format. YOLO has a different annotation, and it has a different format. With this file, Labelme to YOLO, you can annotate and get the JSON annotations and convert it to the format you want to train your YOLO model, which is the YOLO format. And I specify annotations. This is the annotations is the input directory of my JSON, and I specify the output YOLO, and I make a folder called output YOLO, and then I run the code. So this converted, I did one annotation, one JSON, and it put it in the YOLO format in output YOLO. This is the format of the YOLO. It has 3 objects in the image. All of them has the class 0, and these are the center, x and y coordinate of the center, and these are the widths and heights of the bounding box. Each bounding box that you specify, you annotate on your image. It will have the widths and heights and a center, x and y. All of them are appeared here, and these are in the YOLO format. So since you imagine that you have annotated all of them, so you will have like 70 annotations. You need to have 60 for training and 10 images for annotation. And you one more thing that you need to do is to specify a YAML file for training the YOLO, and I specify this in here. First you need to define path, train, val, and names. Names are the objects that you want to detect. Since you want to detect only one object called yarn-corn, it get the 0 number. It starts from 0 and goes to like 1, 2, 3, 4, depends on your custom objects you want to find. And this path should be the absolute path to your data, and the data should be in a folder called data, and then you put images in the images folder and the train images in the train folder. These are the images annotated, the downloaded images from the Google Chrome, and these are all in train. And 10 for validation, I put them here. And then labels are the files that in the train folder. These are the YOLO format text files for the annotation of the objects. So you put it here, and I choose Colab for training the YOLO. Since it's fast and it has a GPU, I don't have GPU in my local system, so I upload all the images on Google Colab, and then I train the model for getting the YOLO model for object detection of the yarn-corn. So we will continue to that task. So now we are going to Google Colab to train the YOLO model. This is the code. First we need to change the runtime to GPU. So we will choose the GPU, and then we connect it, and then we made the data set here, new folder called data, after that we have images and labels folder, new folder, images and labels. In images we have terrain and validation. Train, and val, and here and in labels as well. train and labels, train and value. So for trying, I just upload these images, one, so right here, 1, 2, 3, and 5, and labels, 1, 2, oh, I made a mistake here for the labels. 1, 2, 3, and 5, like here, 1, 2, 3, and 5. So now we put some images for validation. For validation, for labels. Labels will be the labels folder, validation, and the 4 one. The 4 one will be in validation, and then we go to specify the clone YAM file. Here we upload the YAM file in Google Colab, and this is the clone YAM file. Here we put it here, and then we get the path of data because we need to show the absolute path of data here. I choose this one, and these are the relative paths to the train and validation data set. So this is the saved YAM file, and I go to install the Ultralytics. So you need to put all the annotated and all the images in the data file. I just show for clarification how you should do the procedure, so you can put all your images, training images, in the train folder, and also the validation, the images for validation in validation folder, and the corresponding labels in their label folder as well, like train and validation. So you should put more than this, of course, like the 60 images at least. And if you have downloaded more Yarncorn images, and when they are verified, you should validate the images. Some images are not exactly the images of Yarncorn, so you should get rid of them. You should clean them and annotate the rest, and put the rest with annotations in the data folder. and then it's ready for training. So I'm waiting for installing Ultralytics, and I use YOLO version 12 for training. So I think it's done. No, it's not done yet. I wait till it's finished. So it's finished, and now I'm going to train the model with this script. First, it needs to download the YOLO version 12. I specified the nano one. It's the lightest one and fastest one. And it's downloaded. It reads the images and labels, the text files. Yes, it's now running to train. Since they are very little images, like 3 or 4 images for training, it trains very fast, but it won't give us a good model since it's not trained on a bigger data set. Before I run it for 60 images for training and 10 images for validation, and I downloaded the models. In here, runs, detect and predict are the results for that, and then I put the train the weights. It gives us the best and the last models. As you can see, I think let's wait this finishes for 100 epochs, and then you will understand what I mean. So it finished. It saves the results in run, detect, and in train, and in weights. There are 2 models, saved models, like the best one, and this is the last epoch model. This is the best one. I downloaded the best one and I put it in both of them in my folder in weights, and I use the prediction label script to predict the how the model works on the test data set. So I run this code and it saves in the result. Now the result saves in run, detect, predict 3. Run, detect, predict 3. As you can see, it's correctly identified the 5 yarn cones with high probabilities. I hope this helps you, and it will broaden your vision for custom object detection with YOLO, the latest YOLO so far, which is YOLO version 12. And if you have any question and any doubts, please write me in the comments. I will read them and answer to you to best of my knowledge and as fast as possible. I hope you enjoy it. If you like it, please share and subscribe, and I will see you in next video. Thank you so much. Have a nice day. Bye.